So when you think database, your mind probably jumps straight to tables, right? Neat little rows and columns. But what if a database could think more like a programmer does? I'm talking about thinking in objects. Well, that's exactly what we're going to dive into today with PostgreSQL. It's this absolute powerhouse of an open source database, and we're going to uncover the object-relational magic that makes it way, way more than just a place to stash your data. So what are we going to cover? First up, we're going to break down what this whole object-relational thing actually means. Then, we'll get into its special sauce. The thing that lets it be super fast and super safe. After that, we'll explore its massive universe of extensions. We'll even build a quick little data model to see it in action, and then wrap things up by looking at why Postgres is just, well, why it dominates the tech world. Okay, let's get right to the heart of it. Yeah, of course, PostgreSQL has all the stuff you'd expect. Tables, rows, columns, but that's just the surface. It's fundamental design. That's where things get really interesting. That's what sets it apart from the pack. And this slide right here, it really says it all. On one side, you've got your standard, traditional database world. Tables, rows, columns. Simple. But then you look at the other side. That's the Postgres world. It doesn't just see a bunch of disconnected data points. No, it sees objects. Objects that have properties and relationships, and it even gets concepts like inheritance. For any developer out there, this is huge. It means your database can finally speak the same language as your code. So what does this actually mean for you in practice? Well, it means you can stop trying to shove your complex, beautiful code structures into flat, boring tables. You can actually create your own custom data types, tailored perfectly for your application. It's kind of like instead of only having standard 2x4 Lego bricks, you get to design your own custom pieces. It just makes data modeling so much more intuitive because it mirrors the way you already think about your information. Okay, flexible data models are awesome, for sure. But they're not worth much if the database just crawls to a halt the second it gets busy. So the big question is, how does Postgres handle a constant storm of reads and writes? Well, it turns out it's got a secret weapon. A little something for both speed and safety. First things first, let's talk about the foundation. PostgreSQL is fully ACID compliant. Now, that's a fancy term, but it's basically the gold standard for databases. It guarantees that your transactions are solid and your data stays correct, even if the power goes out or something else goes wrong. It's the absolute bedrock of trust. You gotta have it. But here's where things get really, really clever. This quote, it just perfectly captures the magic. Think about it. How do you let tons of people read and write data all at the same time without everything just descending into chaos? The answer is simple, but brilliant. You give every single transaction its own perfect snapshot of the database. It's like avoiding traffic jams by just giving everyone their own private road. And that magic trick? It has a name. Multi-version concurrency control, or MVCC for short. This is the special sauce we were talking about. See, most databases lock data when it's being used, which creates these huge traffic jams where everyone has to wait their turn. MVCC doesn't do that. It just gives each process its own lane with that consistent snapshot. And the result? Everybody moves at full speed. We're talking massive, massive performance gains. But wait, there's more. The power of Postgres doesn't just stop with its core features. Nope. One of the things people absolutely love about it is how incredibly extensible it is. You should think of it less like a finished tool and more like a powerful workbench that you can customize with any tool you need to solve pretty much any problem you can dream up. And this ecosystem of extensions, it turns Postgres into a total Swiss Army knife for data. I mean, seriously. You want to build a location-aware app like Uber? Yep, there's an extension for that. Need to scale your database out to handle insane amounts of traffic? You got it, there's an extension for that. What about giving an AI chatbot long-term memory? You already know the answer. There's an extension for that too. It's just endlessly adoptable. And the flexibility train just keeps on rolling. Here's something that makes developers' lives so much easier. You are not locked into just using SQL. You can actually write your database functions and procedures in languages you already use every day, like Python or C. This means you can bring all your existing skills and your really complex logic right into the heart of the database itself. It's a game changer. All right, that's a lot of theory. Let's make this concrete. We're going to walk through a super simple, practical example so you can see exactly how this whole object relational thing works in actual code.
And just before we jump into building our custom type, it's worth remembering just how flexible Postgres really is. I mean, you can have columns that are arrays, like a list of text or a grid of numbers. You can dump unstructured JSON right in there. And of course, the big one, you can define your own object types, which is exactly what we're going to do right now.
Step 1, we define the structure. It's super straightforward. We're just creating a new data type and we're calling it employee. You can think of this like a blueprint for an object. All we're doing is telling Postgres, hey, every single employee object is going to have two things, a name and a role. Okay, step 2. We use that blueprint, we create a new table called programmers. The first column is just a standard ID, nothing special. But check out that second column, person. Its data type isn't text, it's not a number, it's our brand new employee object that we just made. How cool is that? All right, time to add some data. We use a pretty standard insert statement, but you gotta pay attention to the special syntax at the end there. See that? We give it the data as a simple string, and then we use those 2 colons to cast it. That's just a fancy way of telling Postgres, hey, I know this looks like text, but I want you to treat it as one of our custom employee objects. And finally, pulling the data back out. This is where it feels really natural for a programmer. You can use dot notation just like you would in Python or JavaScript. We select the person column, and then we just use .name to grab that specific property right out of the object. It's clean, it's super readable, and honestly, it's just really powerful. So, okay, we've seen the technical side, and it's brilliant, but that's really only half the story. The bigger question is, why? Why do so many developers and companies put their trust in Postgres? Well, it all boils down to a legacy of trust and just relentless innovation. I mean, check this out. Its development started way back in 1986 at UC Berkeley. This is not some new, flashy, flavor-of-the-month technology. It has deep, serious academic roots. It has been battle-tested for decades and improved by a massive global community, which is how it evolved into the absolute powerhouse it is today. Think about that. Over 35 years. In the world of tech, where things change in the blink of an eye, that kind of longevity is almost unheard of. It's just a massive testament to its rock-solid stability, its incredible performance, and that amazing community that just keeps pushing it forward. This is the kind of foundation you can literally build a business on. So let's just end on this thought. Here we have a database that was born in the 1980s, and yet today it is at the absolute forefront, powering cutting-edge AI, complex geospatial apps, and huge, massive-scale platforms. With its incredible ability to adapt and evolve through extensions and that flexible data modeling, the real question isn't what it can do today. It's what new, mind-bendingly complex problems is it going to solve for us next.